This is Hacker Public Radio episode 3359 for Thursday, the 17th of June 2021. Today's show is entitled Linux Inlaws S01E32, Politicians and Artificial Intelligence Part 3 and is part of the series Linux Inlaws. It is hosted by Monochromic and is about 47 minutes long and carries an explicit flag. The summary is part 3 of the miniseries on deep learning, politicians and other approaches to intelligence or not.
This episode of HPR is brought to you by archive.org. Support universal access to all knowledge by heading over to archive.org/donate.
This is Linux Inlaws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever fancies you tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy Mom? Thus, the content is not suitable for consumption in the workplace, especially when played back in an open plan office or similar environments. Any minors under the age of 35 or any pets including fluffy little killer bunnies, your trusty guide dog, unless on speed, and QT Rexes or other associated dinosaurs. So welcome to Linux Inlaws Season 1 Episode 34, the one with the framework. Martin, how are things?
Things are wet, cold, and windy, as in a typical UK summer.
I see. Well, hang on, Martin. I just got a mail from the Metropolitan. No, sorry, not Metropolitan. Metropolitan Police Force. Yes. Who apparently
squad on your case again, are they? Like,
who not only
run all these pipelines.
Who not only run the government these days in the UK, but apparently are also in charge of the weather.
Excellent. That's what you need.
Metropolitan Office, well done. Sorry, Metropolitan Police Force, well done. No, the Met Office, yes, got in touch and said that, please tell Mr. Visser that, as usual, the summer won't happen before the 13th of August around 12 o'clock midday.
August? Oh, no, it's usually over by then. Yeah.
No, you're confusing that with 1 p.m. on a set date. There is a difference, you see.
That's true. I thought I stopped a lot earlier than that. But yeah.
Okay, jokes aside, yes.
Jokes aside, indeed. How are you?
Not too bad. Well, the weather isn't great here either, so...
okay.
But apparently our summer is now planned between July 30th and August 22nd. So that gives us almost 3 weeks or something. In contrast to an hour in the UK.
Right. Yes.
But then you did want to live in this country, Martin, right?
Yeah, it's got the advantage of not so much lager and stuff like that. So.
Yes, but we won't go.
What wonderful weather!
Yes, we won't go down the avenue of lukewarm kit pads. Exactly. Cat piss for a change.
Interesting. What's a kit pass? Yeah.
That's a very good question. Sorry, cat piss, also known as real ale. Camera, if you're listening, this show is about you.
You're clearly
and your
after their
futile
sponsorship again, aren't you?
and your futile attempts to introduce real beer to the world, which other people
No. We don't want to
consider.
introduce it to the world. It's they don't appreciate quality like that.
Quality. Interesting. Do the cats know that you're taking away their piss?
Yeah.
Okay, before this derails any further.
Yes. Well, we can always invite the grumpy old co-hosts. We want that.
Yes, but they're busy tonight, so it's not an option. Grumpies, if you're listening, get in touch.
Yeah.
We need you. Okay, back to today's subject, which is of course the third installment. The third installment of the 27.64.
It's many years of
parts.
material.
Yeah, parts of the mini-series about artificial intelligence and other humorous aspects. And this one will be about frameworks.
Okay.
Maybe we should do a very quick recap for the two listeners who are not in the loop with regards to what has been happening so far with our two superheroes in terms of what we did for the first two episodes.
It's been a while, hasn't it? Why don't you go first?
By all means. During the first episode, Martin tried to introduce the foundation of artificial intelligence without using maths. That, of course, was crowned by success. I'm almost tempted to say. No, jokes aside, in the first part of this miniseries, basically we tackled the theoretical foundation. So what are backpropagation networks, how they work in principle, what are the different entities that make up a backpropagation network, and why they're important for deep machine learning. The second part introduced two major frameworks, namely TensorFlow and PyTorch, two infrastructure projects in the area of backpropagation networks. The idea behind these two frameworks is essentially to give you a programming model at your disposal so that you don't have to reinvent the wheel, but rather can get started right away. Because most of them, for example, would provide a Python integration right out of the box. Meaning that you can start to compose your layers, interconnect them, all the rest of it, with a few simple commands. This is the idea behind these kind of infrastructure layers known as TensorFlow and PyTorch. Did I forget anything?
Sounds about right. Yeah. It's been a while, as I said. So.
Yes.
But it's a good summary. Well done. Full marks.
Full disclosure, Martin is over the age of 42.
Just. Anyway, 42 is a good number.
Sorry, 40,2, exactly.
Yeah. Anyway, let's not go into 42 today. Is that another time?
Yes. Okay. And continuing in this kind of frame of thought, let's put it this way, there are, of course, additional frameworks on top of said PyTorch, or Torch for that matter, and TensorFlow.
Okay. What are you particularly thinking of there?
The old time, as in terms of at least my favorite, comes to mind, Keras.
Okay. Why do you like Keras? And what's it do?
Because that's the first one I met. Ages ago, yes.
Traditionalist, are we?
Indeed, very much so, yes. Why do I like Keras? Until version, I think it was 2.3, it supported multiple backends. After that, some... If I say no moron, people will send nasty comments, so I won't say moron, but some steering committee decided to just pick TensorFlow as the only available backend for Keras, which kind of limits the infrastructure behind Keras a little bit. But the idea behind Keras is essentially to give you functionality on top of generic TensorFlow, or for that matter, other backpropagation network infrastructure frameworks prior to version 2.4. The idea is, for example, at the end of the day, machine learning is all about pattern recognition, and Keras is pretty good at something, for example, called image recognition, say.
Well, there's other things you could use for that, but carry on.
Absolutely. So, and the idea behind image recognition, for example, if you want to spot the difference between, say, a human and an animal, basically, one of the easiest things, basically, to differentiate between these two beings is actually to take a look at their faces.
Well, but that would require some intelligence, right?
Well, hence the word deep learning or artificial intelligence, no?
Mm-hmm.
So the idea behind
spotting... you say that, but if you remember, I don't know if we touched on this in one of the previous episodes, but in a way, the deep learning frameworks are very primitive in the way they learn, right, compared to humans. I think we may have touched upon that. You'd have to feed them, thousands and thousands of examples before you get a decent error rate out of them.
And that was, of course, before Skynet 3.0.
Well, you mean humans?
No, generally speaking.
Uh-huh.
The idea is basically, if you want to spot the difference between, say, an animal and a human being, all you have to do is, being a somewhat intelligent entity, you have to take a look at their faces, because humans have a certain, what's what I'm looking for? Facial expression that you cannot find in animals. Plus, the composition of said faces is different.
I don't know. It seems like a very odd thing to do. You may as well look at, are they wearing any clothes, right? Isn't that much easier as a distinction.
In that case, you would have to have access to the whole being just instead of a face. But sometimes you only have a certain part of the entity at hand.
Okay, that's fair.
So, and if you get to choose, of course, your preference would be a face, because humans have a face that is easily recognizable. You have at least.
No. Why not go for the shoes? Because then you have a definite. If it's wearing shoes, it's a human. If it isn't, it's
this is Martin's female side. Full disclosure. Martin, how many shoes have you bought today? Just 20?
No, I don't buy shoes very often, since my feet are not growing anymore at my age. Now, if I was in less than 20 years old, then I would be buying shoes on a frequent basis.
Yeah, but Martin, I get all these complaints from your wife that actually your shoe collection is bigger than hers.
It's unlikely.
Well, we won't go into the finer details, but I have it in writing. Let's put it this way. Anyway, going back to the much more safer ground of facial recognition. For example,
facial recognition. Okay,
yes.
So,
humans have normally a nose. Humans have 2 pair of eyes. Humans also have ears, and humans have a mouth. Only
people only have one eye. Are they not human?
Well, we will go into the borderline cases in a minute, Martin. Bear with me.
Sorry.
If you take a look at the so-called animal kingdom, only very few species come to mind that have a somewhat remotely similar facial composition, namely what are called primates. Any other animal looks quite different. For example, elephants have trunks.
Well, and lots of them have fur as well, right?
Yes. Lions basically have really different ears, if you can see them at all, and so forth. So the idea is essentially, with that pattern recognition stuff, as an image recognition, what you want to do is actually you want to extract certain features. If these features then match a certain predefined pattern, you can derive, by taking a look at the composition of said features, that you have a certain class of image right in front of you. And this is essentially how image recognition works. And for doing so, you need special layers in your backpropagation network.
Okay, why is it special?
Because you need a special, let's put it this way, configuration of layers, for example, for something called feature extraction. The way it works essentially, if you have a bitmap, you simply start to extract shapes. If you progress this far enough, essentially, you can match these extracted shapes against predefined patterns. Should these shapes to match to some extent, you can be sure that these shapes fall, especially with the shapes at a certain position of a predefined kind of form of the shape, that you have a certain class of animal right in front of you, or entity, let's put it this way. And because of the different composition of these backpropagation layers, they have different sizes, the connections are different, all the rest of it. These are normally known as convolutional networks, because the different layers in charge of feature extraction, feature composition, feature recognition, that sort of thing, are composed differently. Different sizes, different connectivity between the layers and all the rest of it. You will find the links in the show notes with regards to further details, because we want to keep this to a 4-hour length with regards to the overall episode. I won't go into the details.
There is actually a case for using those types of applications, not just for image data, but using whichever data set you have and representing that as an image, because those networks tend to be quite well performing at certain tasks which can be represented even in an image. For example, I don't know if you're familiar with the fraud detection use case for mouse movement.
As a matter of fact, I'm not. Why don't you do a little bit of explaining? Actually, that sounds very interesting.
I can do some explaining. Right.
Please.
So if you track the coordinates of people's mouse movements, you can imagine that as a picture in front of you over time, right? So lots of lines where the mouse moves up and down, left and right, and so on. And
sorry, Martin, just checking. Is this PETA compliant?
Again.
Is this PETA compliant if you move your mouse?
Well, if you have a mouse, yeah, why not?
PETA rings a bell. It's this animal protection organization. So if you want to move your mouse very often, you want to make sure that this is PETA compliant. No.
Well, if you're using that kind of mouse, you probably want to fit it with a tracker so that you can make sure it's your mouse with machine learning based on its movements.
No, we're getting somewhere, Martin. Please do continue.
Yes. Anyway. So that's one of them, right? So plot the mouse movements as an image, and use your image methods to recognize whether it fits previous behaviors for said user. So that's one. There was another one.
What's the advantage of tracking mouse movements apart from having PETA on your breathing down your back?
No. The advantage is that everybody has very unique mouse movements based on.
So this is user identification.
Yes.
Instead of extracting eyeballs and tracking them and stuff and whatever.
Yes, but the point is that the mouse movements can be represented as an image over time, right? So you have you can imagine a picture with lines of set movements, because they're just coordinates, right, on a grid.
Indeed, yes.
So this is something that, interestingly enough, people used to build all sorts of different systems to try and do fraud detection on, say, mouse movements, not based on images, where someone had the clever idea to shove it in an image recognition method instead, and found that it's performed a lot better than any of the previous ones.
Interesting.
Yeah.
And you used a backpropagation network infrastructure for this?
Indeed.
You know which one?
I don't know off the top of my head. I think they actually had created some IP around it and started the company and all sorts of stuff like that.
So it's not exactly open source.
No, but we're not specifically talking about open source today, are we? And another one you can consider is I think someone did some research in the area of malware, and again, if you can imagine your zeros and one as a binary picture, right? You can just turn your bits on and off, and again, when people investigated or researched this area, they found that using the image recognition on the image representation of the actual bits and bytes of that malware was quite successful compared to lots of other methods that they used before. So as a kind of side note, there are a lot of ways that you can think about to represent something as an image and use the image recognition ones networks for purposes of obviously through the training that you want to get out of it. But makes sense.
It does indeed. And I mean, the beauty with kind of these more abstract frameworks like Keras running on top of your PyTorches, on top of your TensorFlows, is of course they provide you with an abstraction layer, with an infrastructure abstraction, let's put it this way, that you would otherwise have to do yourself. For example, using Keras, convolutional networks, as in how to define them, how to implement them in TensorFlow, come with the framework. So this is essentially just a few API calls, and then you have your convolutional network built, including feature extraction and all the rest of it. With plain TensorFlow or with plain PyTorch, the implementation effort would be quite higher because you would have to do it all yourself.
Yeah, very true. Do you have any other ones apart from Keras that you can think of?
There's quite a few. This is links will be in the show notes.
Okay.
But all of them basically have their different advantages, different disadvantages. The reason basically why I'm mentioning Keras is that it runs on TensorFlow and it used to also run on PyTorch natively. And these would be the two most prominent backpropagation infrastructures currently used in the industry with regards to deep learning, machine learning, all the rest of it. I mean, there are quite a few other approaches, just to name a few, if I can recall them kind of correctly. For example, there's a Apache project called MXNet that gives you similar functionality, like convolutional networks and other stuff. Of course, there are also other approaches like recurrent nets. You have, what are they called again? Deep belief networks. You have.
I don't know that one. Why do we need a recurrent network?
It's a typical set of pattern recognition that is modeled by recurrent networks pretty well. Okay,
and this is because a convolutional network doesn't store any state. Or...
It boils down to how the individual neurons or how the individual modeled entities reflecting neurons are composed. Taking this onto that technical level of detail probably would confuse most listeners. So the show notes will contain links to a level of more detail that you're happy to take a look at if so required. And a deep belief network is essentially an extension of a what's the word I'm looking for?
I'm not familiar with the deep belief network. It's
of a neural network essentially that covers particularly that covers a particular set of use cases.
Okay, that is not heard.
Yes, it basically it's good at a particular set of classifications. Again, details will be in the show notes.
Okay.
So the point that I'm making here is that different deep learning frameworks cover different aspects. Like some of them implement deep belief networks, some of them implement convolutional networks, some of them, or most of them basically would implement recurrent nets. So the idea is essentially, as usual, if you have a particular use case at hand, simply take a look at at the technology that's fitting your thing, and then just go for it.
Mm-hmm.
The thing is,
so
go ahead, Mark.
Sorry. Do you want to finish what you're saying?
The thing, of course, is that the emerging standards are pretty much PyTorch and TensorFlow.
Indeed.
Because, for example, if you take a look at cloud environments, most of them would support one or another out of the box. You get something called TPUs as in TensorFlow processing units, and something called Google. Microsoft has something similar, and other hyperscalers, please check the offerings if you're so inclined, also support TensorFlow and PyTorch out of the box.
Yep. Yeah, so as you say, there is obviously depending on what you need from in terms of use case application, you're going to look for. But most of these frameworks will support your CNNs, RNNs, etc. If you want to do image recognition, or if you want to do generating text or music or whatever it is you want to do, then you need to look at which one is the best one and so on. But yeah, we've spoken about that in the first episode, right, about the typical applications and so on. Okay.
What is, of course, important, most of them actually would offer an interface to something called Python. Given the fact that this is a programming language rapidly evolving as one of the premier choices for machine learning and big data in general, things like notebooks and all the rest of it are readily available for the majority of these frameworks. So it's fair to say with Python, you have a head start when using them.
Definitely. To be frank, I can't think of any other. Well, there was, some years ago, people used to use different types of software, right, before the more recent rise of the PyTorches and the TensorFlows. But that was all. Yeah, it was a bit more bespoke, right? And
that was more like Skynet 1.0, right?
Indeed. Yeah. Now, I guess, sorry, I won't mention the hardware in this case, but since we were on a
Why not?
Well, we're on a framework episode, aren't we?
Martin, if you want to plug NVIDIA, that's fine by me. Just go ahead.
I don't want to plug NVIDIA, but what's interesting is that
and NVIDIA, if you're listening, there's a special email address for you. It's called NVIDIA_sponsoring@linuxinlaws.eu. Feel free to get in touch if you want to send us money.
Yeah. I mean, NVIDIA are obviously the biggest GPU manufacturer in the world, I think. Yeah, that's probably got to be true, isn't it? Intel are trying a bit, but the likes of Google, as you say, have built their TPUs, right, for...
But I mean, hang on, Martin. If you're counting built-in GPUs into the SoC, I reckon Intel has a head start here, no?
True. Well, I don't know. There is a distinct takeover, or not takeover, but Intel is on the decline, right? Because Apple built his M1 and AMD is doing quite well with his Threadripper CPUs and so on, which are
Intel is on the decline, okay? So have you sold the Intel shares, Martin?
I don't have any.
You don't? No, now, of course, because you've sold them all, right? I see.
I put this all in NVIDIA now.
Very good, Martin. Smart move.
Yeah.
Intel, if you're listening...
I ran RNN on it beforehand.
Intel, if you're listening, the email address intel_sponsoring@linuxinlaws.eu is no longer valid. You heard it here first.
Well, I don't know. If they email us, we could do a special episode on... how they are turning everything around and becoming the chip manufacturer of the future.
Well, Martin, I wouldn't go as far as ruling them out completely yet. I mean, they still have a kind of marginalized right for existence now.
Yes, no, it's very true. I mean, I think all my stuff runs on Intel.
I mean, yes, especially if given the fact
I
that
can't afford a Threadripper, but there we go.
especially given the fact that not all hyperscalers actually use M1s in their cloud environments. Not yet, anyway. Apple, if you're listening, your stuff is just too expensive. If you lower the prices, the hyperscalers might be tempted to take a look at you. But at the moment, forget about it.
Oh, it's always going to be too expensive, isn't it? It's
Well, it's Apple, right?
Yes, it's overpriced bling. So.
Exactly, it's marketing. Just take a look at the iPhones and iPads.
Well, working marketing for change. Yeah, that's anyway. Well done. Right, where were we?
Yes, Apple. The email address to use is apple_sponsoring@linuxinlaws.eu. In case you want to get in touch or something, I don't know. And yes, of course, we will review some of your kit if you just send a decent spec to us.
Yeah.
Decent spec that would be an M1, a terabyte of this drive, and at least a terabyte of main memory. So we can do something with the machine.
Yeah, unlike just running the OS. Yeah. Indeed, good thinking.
Please make sure that you do not send this before the fourth quarter, so we can actually put Linux on it, because the chip support is just entering the kernel now.
Oh, cool.
Needless to say, because we don't want to run OS X on that machine.
not ideally. Yeah. Okay. So we digressed a bit, but
yes, indeed. Back to the topic at hand.
The topic at hand. Where were we?
I think frameworks on top of backpropagation infrastructures.
Yes. Okay. Right. So you mentioned image recognition for Keras. What else can you do with Keras?
Well, any pattern recognition comes to mind, right?
Is that its main?
I mean, you mentioned fraud detection. Yes. I mean, at the end of the day, if you're looking at organized crime, doing fraud detection is all about pattern recognition, because you want to correlate single incidents.
Okay.
At the end of the day, take a look at a credit card fraud. I mean, if you use the same credit card number, say simultaneously in Singapore, Berlin, and New York, there's little point at looking at the individual transactions in isolation. Only if you correlate the timestamps, as in if you identify a pattern, you can detect credit card fraud on a grand scale, because it's that sort of timestamp association that gives you that pattern that actually a credit card number has been stolen and is used simultaneously all over the shop as in Planet.
So your argument here is that rather than having a rule-based system that has a built-in compare timestamps for transactions scenario, which is one way of doing it, you would have instead use your machine learning model to determine patterns on all sorts of different attributes of these types of transactions.
Absolutely, because credit card numbers, as maybe a few listeners know, are allocated in blocks based on geographies, based on credit card companies and all the rest. And to drive this really home, this message, if you can predict actually based on certain pattern the next fraud incident, you can actually send the cops to that to that location before the fraud actually happens.
Didn't someone make a movie out of that?
Yeah, it used to be the case, but MasterCard, Visa, for the finer details, please get in touch. I'm sure we can work something out on a commercial level.
Yeah. No, it's called my Minority Report, isn't it? That movie I'm thinking of. Yeah,
but that's 20 years old, no?
Oh, it seemed to have been implemented by MasterCard in real life.
Fair enough.
Yeah. Okay. Cool. What about something like scikit-learn?
What's this?
Well, it's quite a popular framework on top of Python that people use instead of, say, Keras?
I only know Keras, Martin. Why don't you explain the whole thing a little bit?
Well, it's just something that a lot of Python people, data scientists that I talk to, they tend to say, "Oh, we use that," and but if you knew why.
I don't.
Okay. No, I can't tell you. I will ask the question next time. Yeah, but I think it's more. It's a toolkit to do many of those tasks that you mentioned, like classification and clustering, and it's a Python on top of Python, including. I mean, you must know about SciPy now.
Of course.
Yeah. So it's using SciPy, it's using NumPy, all kinds of stuff like that. It's just kind of a big library of things that you can use to do your machine learning.
I see.
And using the underlying, some of the underlying existing stuff like SciPy and Matplotlib and stuff like that. That's already and NumPy, of course. Yeah. Putting it all together in one handy library for machine learning.
Interesting. The links, of course, will be in the show notes.
But yeah, that's I've spoken to a few people recently, and that's the one that they tend to look at first before they go anywhere else.
Okay. So this is the hipster code, not Keras anymore. Okay.
Well, I don't know. It's it's a small sample I've spoken to, so who knows, right?
It depends on who you speak to, Martin. I mean, if these are the movers and the shakers of the industry, you might be onto something.
Yes, yeah, that's true. Well, I mean, obviously, certain companies dealing with GPUs, making software on top of that are the future, as you may know.
Until that swindle blows. Counting any minute now. Can't be too long now, can it?
What, so are you saying that nobody's going to use Redis anymore?
No, I'm talking about this GPU database swindle.
Well, I think, I don't know, NVIDIA's got a pretty big market cap these days, right? I don't know what it is, but I think they're doing pretty well. There are clearly benefits to using GPUs, specifically for machine learning.
Absolutely. Never mind doing SQL database queries.
Indeed. Yes, who needs NoSQL? It's all this old.
This is rubbish,
stuff.
Exactly, yes. Yeah. Going back to the real SQL stuff, of course, yes.
Yes.
All those, forget about this newfangled NoSQL stuff, exactly.
It's not that new anymore, right? So.
But before we derail this episode even further, I think we should wrap this up. No? Yes, maybe?
Yeah, why not? Good plan. Many links in the show notes.
Yes.
Okay. Well, before we do that, what is your where do you use any of this in your infrastructure?
I can't really talk about it because that would imply that each and every listener would sign a separate NDA as a non-disclosure agreement. So these two listeners out there, please,
send your details.
NDA, yes. Please, get in touch. The email address is feedback@linuxinlaws.eu. Please send your details to feedback@linuxinlaws.eu. We send you an NDA, and then we can talk about this. Sorry, I can talk about this.
Yes. Okay, fair enough. Sounds like a good result. So you don't use it for anything you can talk about. That sounds good.
That I can talk about, exactly.
Well, I mean, we had a previous episode on the speech recognition, right? So that's obviously one application. It's a bit difficult doing a podcast on image recognition. So we won't do that one, but it is another application that I use it for.
Do you want to tease the final episode of this 27-part miniseries, Martin, before we wrap this up in terms of boxes and stuff?
If you like.
Sorry, the question was if you want to tease, as in the emphasis is on Martin.
Oh, sorry. I want to tease it. Okay.
Yes.
Well, so, yes. Okay, now this is obviously aimed at 100% of our audience. All two of you. Episode 27 will be a A podcast on image recognition.
Does it?
Where,
Will
where
it?
you
Okay.
where you cannot see anything.
Very good, Martin. Very good. That will bring
But
down to our
all will be clear.
Yes, that will bring down our listenership to one listener. Fair enough.
Well, no, okay. So the reverse process is also possible, right? So you can represent sounds as images, which people do to do speech
True.
recognition.
Yes.
So you can also do the reverse, right? You can turn an image into sound, but then it may be just some noise. Be prepared for an hour of noise.
Excellent.
Or more
Excellent.
noise than usual.
Which nicely leads us to the POXes, of course, and the POXes being the Pixels of the weeks. Yes. So Martin, what's your POX?
My POX of the week is Live on Mars.
Is there life on Mars?
No, it is a television series.
Sorry. Okay.
Which is quite amusing. It's a few years old, but I've never seen it yet, and it is now available on something called BBC iPlayer.
What's BBC iPlayer?
BBC iPlayer is the streaming service by the BBC.
That probably will require a British IP address, right?
It does require a British IP address, but those are not hard to come by.
VPN providers, if you want to get in touch, the address is sponsors at linuxinlaws.eu.
First one that sponsors, we will name your name.
Yes, exactly. Okay.
What about yourself? Oh, I haven't told you what it's about anyway.
No, just go ahead.
Yes. Well, you may like this. Anyway, it's about a story about a guy who is a policeman in current day time, and he has a car accident. And when he wakes up, or thinks he wakes up, he is in 1973. And so the end of the story isn't clear yet. But so the question is he in a coma? Has he really gone back in time? Or is he on Mars? I'm not sure when the Mars connection comes in yet, but it's a really good story because it's kind of 1970s policing in the UK depicted very well. So it's quite amusing that way.
And how exactly does Mars feature in the whole thing?
I don't know yet. I haven't got there. I've only done series.
Okay.
I don't have the answer. Yeah.
Okay.
So listeners, if you're listening, don't send feedback on this, or I will kill you.
The email address, listeners, to send that sort of feedback to is teaser at
yes, don't send it to the normal email. Yes. Indeed.
So
what about your POX of the week?
In a minute, so that Martin can enjoy the full end of rest of the episodes without having to watch them. So that's always appreciated. Of course, my POX would be living under Snickers or living next to Twix or something. No, yes, maybe.
No, I'm not eating that many Mars bars at the moment. I don't know about you.
Fair enough. Some people get the pun, some don't. That's okay, no worries. No, it's actually a movie called Limitless, where a guy called Bradley Cooper,
sounds vaguely familiar.
His real name now, not a character he portrays, plays a guy who, after a certain indulgence of a specific drug, changes his life. Let's put it this way.
What's it called?
Limitless. It's about, I think, at least 10 or 15 years old.
I think I might have seen this.
Quite funny, actually, in certain parts. And for example, it teaches you how to bang your the wife of your landlord by just remembering certain law book. For the rest of the details, please check out the movie. Of course, links will be in the show notes. It's quite, as I said, it's quite funny, and it tells a story about how to broaden your mind by chemistry. Let's leave it at that.
Are you looking for sponsorship by the cartel?
That's already in place.
Okay, fair enough.
Horrible. And with that, of course, feedback is always welcome. Negative, positive, yes, doesn't matter. Even on Mars, Snicker, and Twix. The email address is feedback@linuxinlaws.eu. We would like to thank, as usual, HPR as in Hacker Public Radio for hosting us. And Ken, if you're listening, I'm sure you will, apologies if the infrastructure screwed it up recently, or will be fixed, I hope, during the next upload.
Did you break something?
I normally do, yes.
Okay. You were doing some QA testing of Hacker Public
Indeed,
Radio.
yes.
Okay, well, I think we probably end there before you expire.
Yes, expiration is soon.
Thank you for listening.
Thank you for listening, and see you next time. This is the Linux In-Laws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
This podcast is licensed under the latest version of the Creative Commons license, Type Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for the song Salute Margot, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under Creative Commons at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.
Yeah, so...
Shall we get this going?
Yeah, sure. What are we doing today?
Talk about nonsense as usual.
Oh, by the way, yeah, so Intel's market cap is $226 billion. And what's bigger, NVIDIA or Intel?
I'm tempted to say IBM.
IBM? I
Yes.
didn't ask for IBM.
But that's my personal opinion.
IBM, do they still exist? Oh, it's because they bought
Yes, they do.
Yeah,
Yes,
okay.
they do. But
No, they're even smaller. Wow, IBM is the smallest.
smaller than Intel.
Smaller than Intel, and Intel is smaller than NVIDIA. There you go.
By what? $2? Maybe
No.
$3?
Right. So Intel is 130 billion roughly. Sorry, no, IBM. Intel 226 and NVIDIA is 3 something or other, 360. There you go. So, yeah.
And the reason for this is that NVIDIA bought back quite a significant amount of shares.
I don't know about that.
Because if you do
I'm
this,
not in charge of the finances. I'm glad to say.
Because if you do this, basically shares come more expensive. That of course will increase the market cap.
Oh, but where have I heard this before?
Michael Dell, if you're listening, it still works.
Circle NoSQL database comes to mind as well.
Does it now? Okay.
Yeah, not the one that you work for.
No, because they have noted yet, Martin. Well,
they don't
spotted.
have any shares. Indeed.
You've been listening to Hacker Public Radio at hackerpublicradio.org. We are a community podcast network that releases shows every weekday, Monday through Friday. Today's show, like all our shows, was contributed by an HPR listener like yourself. If you ever thought of recording a podcast, then click on our contribute link to find out how easy it really is. Hacker Public Radio was founded by the Digital Dog Pound and the Infonomicon Computer Club and is part of the binary revolution at binrev.com. If you have comments on today's show, please email the host directly, leave a comment on the website, or record a follow-up episode yourself. Unless otherwise stated, today's show is released under a Creative Commons Attribution Share Alike 3.0 license.